Hi everyone, I'm putting this video together to show you how to use BCA tables to solve limiting reactant problems. You can use BCA tables really for any problem in stoichiometry. I just find that BCA tables are especially useful when working with limiting reactants. Okay, so I'm going to set up a really simple problem for this video. All other problems are basically going to be like this one. I'm just going to use very simple numbers so that you can see very plainly what I'm doing to solve these problems. All right, let's give this a try. I'm going to use this equation. So 3 moles of hydrogen combines with 1 mole of nitrogen to make 2 moles of ammonia. Here's the problem that we're going to solve. All right, so if we combine 5 moles of hydrogen with 2 moles of nitrogen, how many moles of ammonia can we make? Now, anytime that you're given both quantities of both reactants, you've got to find which is going to be the limiting reactant, okay? It's going to be really rare that you're given exactly the right amount of both ingredients so that they both react completely together, all right? So, in other words, if you're given the quantity of both reactants, you've got to find the limiting reactant. And then once you find the limiting reactant, you can find how much stuff you can make. Okay, so here we're given 5 moles of hydrogen, 2 moles of nitrogen. How many moles of ammonia can we make? All right, I'm going to set up a BCA table now. Okay, so here's my BCA table. I set up the equation, and I drew a table underneath that equation. Under the plus sign, I drew a line. Under the arrow, I drew a line. B stands for before, so this is before the reaction starts. C is the change that happens during the reaction. And then A stands for what do we have after the reaction is finished. All right, now, let's fill in this BCA table with what we're given. Okay, we're given 5 moles of hydrogen. We're also given 2 moles of nitrogen. Okay, now before the reaction is started, we haven't made any ammonia yet. Okay, now we've got to decide what is going to be the limiting reactant. Now, let's just try using up all 5 moles of hydrogen. If I use up all 5 moles of hydrogen, I will end up with 0 hydrogen at the end of the reaction. Okay, or when the reaction is finished. Okay, the limiting reactant, we always use up all of the limiting reactant. All right, now, this is where we really need to think, all right? For every 3 hydrogens that we use, we need 1 mole or 1 nitrogen. So for every 3 hydrogens, I need 1 nitrogen. Okay. So now, if I'm going to use up all 5 of the hydrogen, I'm going to use 1/3 of 5 to see how much nitrogen we're going to use. 1/3 of 5, and you can do this on your calculator, will be about 1.7. I think it comes out to be like 1.6666666. Blah, blah, blah. Okay. So for every 5 hydrogens that we use up, we're going to use 1.7 of the nitrogen. 5 divided by 3 is 1.7. Okay? Again, that's 1/3. Whatever nitrogen we're using, it's going to be 1/3 of the amount of hydrogen that we're using. All right. What does that come out to be? In the end, we will end up with 0.3 moles excess nitrogen. Okay? Now, we've determined here that the hydrogen is our limiting reactant. All right, well, how much ammonia can we make? If we look at this equation, for every 1 nitrogen, I can make 2 ammonia. Okay? So the answer to this question, how much ammonia can I make, is going to be 2 times 1.7. That's going to be 3.4 moles of ammonia that we can make. That's how much ammonia we can make. We're going to end up with 0.3 excess nitrogen, that's leftover nitrogen that wasn't used, and we're going to use up all of that hydrogen. Hydrogen is our limiting reactant. Okay, now, what if I tried to see if nitrogen could be the limiting reactant? Let's give that a try. Okay, I'm just going to write this out and then I'll come back to you. All right, so I wrote this out. Here we're giving it a shot. We're going to see, can we use up all of the nitrogen? Could nitrogen be our limiting reactant? We find that it cannot, right? If I was going to use all 2 of this nitrogen, if I used up all of that 2, I would need 6 hydrogens to use that up, right? So it's impossible. I can't take 6 moles out of 5 moles of hydrogen. So this is impossible. And what I'm showing you here is that you could try one of the reactants to see if it's going to be the limiting reactant. If it turns out that it's impossible, then stop and then just start over again and use the other reactant. Again, this is the only possible answer to that question. All right. Now, also keep in mind before we go, this is all done in moles. If you were given grams, you have to convert to moles because moles is a counted number of things. And remember, we've got 3 to 1 to 2. Those are counted numbers of molecules. Grams will never, ever work in a BCA table. It never works in stoichiometry. You always have to convert from grams to moles. Now, if the question was, how many grams of ammonia can I make? I would have to answer that question by converting 3.4 moles to grams, all right? So always remember, this is all about moles, all right? Stoichiometry is all about moles, all right? I hope this was helpful. I'm going to try some other videos, solving some other problems, maybe some homework problems, but I wanted this to be a simple example that you could follow, all right?